It's Wednesday, January 18th, 2017, and welcome to this episode of Code Evolution. So I've been working really hard for the last month and haven't really done any videos, mainly because this project that I'm working on is, it's really interesting. And it's centered around evolutionary algorithms and genetic algorithms and machine learning, and, really have dedicated a lot of time to it. But along the way, I've come across some very interesting things that I've not only kind of revisited, but also learned from and refined. And I wanted to share those with you, but let's just do one real quick, which is I wrote an article back here in 2013 about synchronization, thread safety, and performance. And I spent a lot of time on this because I wanted to not only, using real code, I wanted to kind of show people what you need to do to get your code to be thread safe and basically eliminate the woes of threading and synchronization. Now, let me go ahead and read this to you just so you get the point here. This article outlines the fool's path to wisdom about thread safety and synchronization. Although I primarily write in C#, this article may be useful across languages and platforms. So that's one of the things I've been doing is I've switched over to using, I'm trying out .NET Core these days instead of doing TypeScript. I'm finding it very cool, and I'm really getting back into it. TypeScript, still love it, but I think I'm going to kind of stick with the .NET Core stuff for a little while, trying to promote that a little more. This is, as you can see here, this is Visual Studio Code. I've been really enjoying it. It's been great. I haven't had any real issues. And it's just been kind of this joy to use instead of the heavier big brother of Visual Studio. Not to mention .NET Core is something that you're going to have working across platforms. There are some hang-ups, but I've kind of got over that, and I'm okay. Now back to the article here. So basically, I want to review with this, and I'm going to give you guys a gift at the end of this, which is that there was I released a lib, which is a set of utilities when I made this that had to do with synchronization and thread safety. And I've actually updated that now, and I've made it a little bit better. And I'm going to talk about some other code blocks here as well. But mainly the thing to keep in mind, if you kind of, just to give you a gist, so you don't have to read this, TDLR or whatever, right? Is that if you can avoid, the key, and most people who know anything about this, if you can avoid synchronizing, do so. That's kind of the beauty of JavaScript in some respects, is it doesn't really have this true multi-threaded thing going on that you need to worry about it. And when you do, it's actually serializing the data back and forth between what would be real threads. So you don't have to deal with this kind of pain. The downside is you really can't take performance to the level that you need it. Synchronization becomes kind of this magic that you're not really dealing with directly. Now, when you start actually going deep into synchronization, you'll find that it's problematic. And so the walkthrough that I give you here is basically talking about the kind of the headaches. So it's like the fool's path to wisdom is that, first you try to do multi-threading and it bites you, right? You're like, ow, what happened? And you start dealing with errors, and then you start going through and saying, well, how do I deal with the errors? Oh, I need to check ahead of time if values exist, and that, might fix the problem, but it doesn't. Then you start getting into locking, which, is pretty common practice, even under the hood when we're talking about synchronization classes. And then you're like, okay, well, how can I make this better? Now, there's some really, to really kind of cut to the chase and not drag this out, the things you have to remember is that there's already existing concurrent classes to kind of help you with this, but they're not perfect. For example, a concurrent dictionary, which I recommend using, whenever possible, is great for most case situations where you're trying to have a collection that you want to be concurrent and you don't have to worry about synchronization. It works great. But a concurrent dictionary has optimistic concurrency. So what happens is when you go to look up a value, and there's basically a get or add method on a concurrent dictionary that's used very commonly, like in cache type operations, it may actually execute your code more than once. So there's a hack for that. You can actually use a concurrent dictionary with a lazy And that lazy, you can give it an instruction that says, hey, I want you to do execution and publication so that it will only run once. So there's a hack there. You don't have to create your own classes or anything, and that's a great way to go. So it'll duplicate the lazy multiple times, but it will only execute your function once. And that's kind of the key trick there. And I can show some examples of that here. In fact, I'll dive into the code that I've been working on. And let's see, I did this within, where is that at here? There's one particular class that I was doing. I think it's in the factory. Here we go. Too big. Let's see here. Yeah, here we go. So we have this registry that is a concurrent dictionary that has a string key, and I give it a lazy. And the reason why I do that is I need to guarantee without any shadow of a doubt that when I ask for the value on this, that I execute only once. Because what I'm doing in this particular example is I'm synchronizing this registry with the order at which things were added. And now if you come in here and you look at this function that I have called register, I go ahead and say, hey, I go ahead and put a flag here and say, hey, was it actually added? And then I go and say, hey, I need to return the actual value that's in there, regardless of what I fed it. And so I generate this string key, and I've got this shortcut here that's it's very helpful. It's a static shortcut, so I don't have to write out the whole type, declaration. It gets pretty crazy after a while. But it basically creates a lazy, and the default is execution and publication. What that's going to do is it's going to guarantee that it only runs once. So here's my basically my closure that runs all the code, and at the end of that I call .value. So what does this mean? What's really going on here? Why am I concerned about this? Because in multi-threaded scenarios, you could have multiple threads entering this method at the same time, and they can get all the way to here and then into the actual concurrent dictionary, and then they can end up running this delegate multiple times. And for most purposes in a concurrent dictionary, that's totally fine. It's like, sure, I'm gonna run it twice, and then whatever the first one that wins, I get the value. But if it's a long-running long-running operation or something like that, it's going to be, well, it's going to be a problem. And also, you kind of sometimes need to make sure that you only do one at a time. So again, the cool hack behind that is using a lazy to do the trick. It's pretty awesome. So moving on from there, I want to get into the rest of this, kind of finish this article up, and then I want to review some of the utilities that I have that are useful, and I've been using them a lot, and also some evolution that's happened there too, which is really cool. So one of the big things that if you're ever troubleshooting synchronization and you're using a lock, it's a really good idea to use timeouts. Anytime you can put a timeout in place, then that way you can kind of go, oh man, this long-running operation is becoming a problem. Now in the beginning, I struggled with this when I first ran into synchronization issues, and I needed to learn this and execute it. And please excuse me if you see a lot of contract implementations here. I removed that out of the .NET Core code because it's a little bit, I just don't want to have any barrier to entry there. But now I've got some code in here that allows you to very easily define a timeout, and it will automatically create a closure structure here for you. So you basically just pass it a closure. You put your code in there, and it will manage the entering and exiting of the lock, which is kind of what people want to do. They want to be like, oh, cool, I don't have to think about it. I just put my code in the middle, and everything does what it's supposed to do. The same way a lock really works is that under the hood, this is pretty much the exact code that locks do. They say, hey, I'm going to enter and then do my little magic here, and then I'm going to exit, and that's pretty much it. Now, if we keep going, right, we're talking about locking. Locking it's kind of a hammer, when maybe you need a screwdriver, right? Sometimes you go off and you do this giant lock on the collection, and you're adding and removing, but in the meanwhile, while you're adding and removing, nothing can read from it, right? So you've basically crippled your performance by using locks sometimes. So you got to be careful about that. Now there is there's solutions to this. Now I've actually implemented some code as part of this library that can actually perform up to, or even in some case, surpass the concurrent dictionary that already exists. And you're going, wait, what? What are you talking about? Well, that's because I'm using a technique where, in some cases it's a little bit, it's going to use up a little more memory. But what it's doing is it's creating a read-write lock, not only on the collection, but it creates read-write locks on individual entries. That way, you don't have to be concerned about, synchronization in any way, shape, or form, and it's relative to each individual one. And also in these cases, I can basically create a dictionary. I can use these extensions, and I have a completely synchronized dictionary with as absolute best performance you could get without any concurrency issues, which is really cool. I don't use it all the time because, again, there's going to be a little bit extra memory overhead, and if I can avoid doing it, I stick with concurrent dictionary and all this other stuff just because it's easy, it's already there, and I don't need to use this code. But now let's get into read-write locks. So read-write locks are kind of the next level up from just a straight-up lock. And what you do is you end up entering a read lock, for example, and you read the data you need to read, and then you exit it. And that applies for write, and there's also one more, which is an upgradable one. Now, how do these work? Well, it's really simple, actually. Read-write locks work like this. When you can have multiple readers, an indefinite number of readers, but you only have one writer at a time. So if you have like 100 threads or whatever, and they're all trying to read, and they're only trying to read, everybody's happy. But as soon as a write comes in, what's going to happen is it's going to insert itself in a line of reads, and then the reads that were already active will be released, and then the write will get inserted in front of them and put them on hold. So no more reads can happen until after the write is complete. So one write at a time, multiple reads at a time. And then an upgradable read lock is interesting because what it does is it kind of acts like a write. It says, well, I'm not really writing, I'm going to read. So what it's doing is it's saying, hey, all you guys that are reading, you can keep reading, but only one basically it's kind of a one at a time thing. And I'm the one that's at the head of the line. And so once the readable one says, oh, I'm going to upgrade to write, then it takes charge from there. So it's kind of a way of cutting in line, basically, which is what an upgradable read lock does. And it's also very useful, and it's something that you use commonly if you're going to be querying a value before writing it, is you'll use an upgradable read lock. Now we can get more and more into this article, but basically what it breaks down to is, we talk a little bit about the DCL pattern, which is basically a way of saying, query the value. Query the value and see if I need to do any work. If I still need to do some work, then lock, and then query the value again, and then do more work again. Then actually do the operation if I still need to do it while inside the lock. That way, because it's one of these crazy things that people even for me, it just baffles me how it happens. But literally between the lines, you can have operations happen, things can happen. So you only want to be doing operations that are atomic and that you can lock on that value and say, okay, I've got it. Now, it's important, this is a really important part of this article. It took me a lot of time and work and research and discussion to realize that DCL is sketchy. And you can say, is it bad juju? And the thing is DCL can fail on you if you're not careful. And so what this is basically going over is it's talking about, how do we implement and use the DCL safely? And, then what ends up happening, right? So in some cases, like I review and I talk about using lazy initializer, which is also really nice. Now, again, that's using, I'm pretty sure under the hood, it's using the interlocked class to actually do the work. Interlocked is a great way to solve a lot of these issues and make sure you're getting things happening atomically. Now here we're looking at the perfect example of the DCL pattern and, where it actually may even, maybe work or it might fail. But we're saying, hey, we have a dictionary. try to get the value from that dictionary, and then which it'll emit out here. And if it is not successful at getting the value, then we need to lock the dictionary, try again, and then if, again, this is kind of like if it doesn't exist, go ahead and add it. And then if we still can't do it while inside of a lock, then go ahead and set the value that we expect to our new value, and then move on and add, and now we're adding into the dictionary inside the lock. So as it says here, the above sample is basically a get or add method. It attempts to get the value if it already exists, and then if not, it will add it. And then again, you're dealing with kind of some performance and stuff, and we're gonna keep going here. And so here it is, right? The conclusion. DCL bad? Yes. Assume it's bad almost always. And the reason for that is here. The real problem with the DCL pattern is that it is most of the time not implemented in a way that does not guarantee to not break the multiple read while no writes rule. Once again, if you've got this far, you probably got lucky, didn't see the symptoms of an underlying problem, or are not really exposing your code to asynchronous environment. And so DCL is, I want to say that DCL is something that, again, double check locking is something that is still valid, but for the most part, you have to be really knowing what you're doing, and it's kind of a thing that you got to be really careful about. Now, the extensions that I wrote kind of take care of a lot of that. You don't really have to worry too much, but still, DCL, you still have to know what you're doing, and if that DCL pattern is actually doing what you expect. Again, we talk a little bit here about some of the concurrent classes, and then we're getting into whole ReadWrite, the extensions that are written, which is you've got this nice ReadWrite lock slim extensions. This link is actually probably out of date at this point comparative to what I have, but I'm going to offer a link in the description. Now, some of these cool features that basically allow you, like for example, I'm kind of reviewing here, you can say, hey, I've got a lock, I've got a ReadWrite lock, and I want to read a value from something. This will manage being able to do that through like a lambda or a closure that you can say, hey, I'm going to do all the work and do it in here. Now, what I've evolved from that, and we're going to go into that now, that I'm kind of, this is a pattern that I've been seeing, and I'm actually kind of into it, is, and I want to go ahead and give a shout out to this guy, I can't remember his name, but he's the one that wrote the Async EX, the Nitro Async EX lib. It's awesome. And I've just kind of ran into it more recently, and I got to give him credit for doing some really, really good work there. And if you need anything that's doing any synchronization stuff that requires like async await kind of synchronization, this is definitely the place to go. I've kind of broken it up into a small group of classes that I can use and kept them inside my library. Hooray for open source, right? But yeah, you definitely. If that's something you need, this is the way to go. But if you're going to be doing synchronization, that's not, not async await kind of stuff, you're not doing it across tasks, and you need like an actual blocking synchronization, I would say use this lib. My lib's pretty awesome. So if we get into it here, what I've done is I kind of took a hint from some of his code and some other people's code, and I've written some classes that act like locks themselves. And this is something you'll see a pattern in other places too. That basically, this abstract class is the base class for all of it, where you can have, hey, I'm going to create a lock, I'm going to pass it a ReadWrite lock slim, and that's going to do the work of kind of saying, hey, when this gets disposed, I'm going to call on dispose to do some custom work, and I'm also going to clear out the target as well. And then we get into this read lock as an example where you say, hey, I need a new read lock. Okay, you got one. And then when you dispose of the read lock, meaning you're done, right, then it exits the read lock. And what's really cool about that is that you can do things like writing, you can use a using statement. So let's see, where have I done this recently? Let me go, if I do, let's see, I think I have an upgradable. Right, okay, here we go. Right, so I refined this class called the lazy list. I'd love to do a review on that, but I won't do that right now. It's something that someone else wrote, but I've kind of made it concurrent friendly at this point. Done a lot of work with it. It's in the lib, and that I'll have in the link in the description. So I needed to have a way of having a lock that would properly enter and exit and be able to upgrade while not having a unique closure, not having another closure around it, because I need to be able to return true. I also need to have the context in here as well. And so the great thing about this is you can use the using keyword to say, hey, I need a new lock, and I need to, my actual ReadWrite lock slim is here, and I need to get that readable lock, and then once I have it, at some point in my code, I need to be able to upgrade it. And then when I'm done, I need to just allow it to exit both the write lock and also the read lock as well. And so that's what's cool about this, is by defining these cool little classes that are disposable, you essentially, when they're constructed, they guarantee that you have a lock ready to go. And in this case, I define that if you do, I allow for passing a timeout, which is also nice. And if you do pass a timeout, it's going to, it'll throw if you don't, it'll give you a timeout exception if it doesn't get in before that timeout. And then simply stated, I can upgrade to a write lock, which will set this new write lock in place. And it won't let you do this twice. And then you can either downgrade from the upgradable write lock, or you can just let it dispose and it'll handle both, which is, again, I think really cool. It's a nice pattern. It really has been useful in this case. Like I said, I've got this one case where I've been using it, but for other cases where maybe you're doing a read lock, it can be really clean. For the most part, I'm using my kind of delegate process here. So if we get into more about these extensions, what you'll see more and more is that, let's see if I go and I'll close up these classes to kind of get out of the way. So it's kind of less obvious here. And then you get into some really cool extensions that are very useful just for ReadWrite lock slims, ranging from, hey, I need to read, and the bool indicates, hey, did you actually get a lock or not with a timeout. I mean, it's a very, very long list and well-documented set of extensions that I think are essential if you're going to be concerned about this kind of stuff. And I'm sure if you get into a multi-threaded environment, you're going to run into this stuff. You're just going to go, oh, why is this my bane of my existence? It struggles. It's just a lot of struggle, you know. But once you're able to have these extensions available to you, it can be really, really useful and helpful to have this kind of stuff. So like, for example, there's even some, I'm trying to find something that's a bit more useful or interesting. Okay, let's talk about this one here, for example. ReadWrite conditional optimized is a specific one that I wrote that is really intended for you being able to go into a collection and cherry pick a specific entry and read write on that and not block any other read writes going on in the collection, right? Which is like, wait, what? So if we look at this, and let me kind of close this and get this out of the way. There we go. What it's doing is, and this is going to go off to other methods as well, but it's basically saying, hey, I'm going to read from the collection. I'm going to get a lock for reading first. On the actual collection, I'm going to check the condition that needs to happen. Hey, is this condition valid? Because if it's not, then I'm just going to leave it alone, right? And then if we actually get a lock, then go ahead and if that condition is met, go ahead and try to get a read upgradable write conditional here, which will then go deeper into and say, hey, all right, well, I'm in there. I need to be able to, let me go ahead and see if I can, now that I've validated the initial read-only condition, which is allowing for multiple reads, I'm going to do my read upgradable, which allows for only one read, and then eventually, if that condition is valid, I'm going to go all the way to write and then keep going. So again, it's kind of a staggered approach that is really the highest level of optimization you can get for this kind of synchronization, basically. Now, there's more to this too. I have another class called a ReadWrite helper, which will literally, like I said, it's one of the things that will convert any dictionary or collection or whatever you want into a synchronizable, concurrent class. So, something that I just as a shortcut, that's not the same thing, I'll bring up here some cool things. Like I have this thing called a Concurrency Rapper, or actually here I've got this concurrent collection base, which has also been really useful. It adds a read-write log slim, and it sets up all the methods for you that you can basically pass it anything, and it will work perfectly well for concurrency. So that the same way I implement a concurrent hash set. I even have a concurrent list, which is one of those ones that it's kind of a debatable thing about, like, people don't really agree with it. It's not going to be the most optimal performance ever because it's locking for every operation, but you're seeing that, yeah, it's for every entry, even though you may not need to, but it's still making it so that it's thread safe and that you can have concurrent operations on it. So that's pretty much it. I mean, you guys can enjoy, go ahead and use this all to your heart's content. I've used this a lot, and I've used it in very heavy multi-threaded scenarios where it just runs like a champ, and it's been really great for me because once I run into an issue where I'm like, oh man, I need to synchronize, well, I better get on it, and this is the way that I do that. So, I'll put the link in the description, and we can kind of go from there. Again, if you have any questions about this kind of stuff, don't hesitate to ask. This stuff's really hard for most people, and believe me, there was a point in time where I was dreaming that I would never run into this, and I would never have to be concerned about it ever. And lo and behold, I had to. So anytime you have to do any multi-threaded stuff, you're going to run into this. Unless you're doing JavaScript, which you'll have a whole different row of like, well, why is my data in this thread not the same as the data in this one? So yeah, that's another problem as well. So this has been a kind of impromptu video. I hope that it helps somebody. And it's been over a month since I put out a video because I've been doing this kind of stuff. I hopefully will put out some more cool utilities. And in the meanwhile, I'll share out a link to this repo where I've got some really cool stuff. Like I've got this thread safety class that was really, really useful for a lot of crazy things. ReadWrite Helper is going to be kind of some magic, but it's amazing what it can do, being able to synchronize on individual entries in a collection, but also kind of clean up those locks automatically. I added a bunch of different little cool classes in here that's kind of useful. So till next time, happy coding, and we'll see you then.